Hey, good morning. So this is going to be pretty short and simple video, simple concept, but we still need to discuss it briefly. And it's going to involve, let's see, we're going to talk about physical and chemical changes and properties, right? There we go. I'm not sure if that's in your way, so I'm going to move that down. So that's what we're going to talk about. It's pretty simple. When we discuss our, let's talk about our changes. When we talk about our physical changes, the most important thing to realize is that atoms are not rearranged, right? Atoms are not rearranged. And that's another way of saying that the composition does not change. Okay, so some students they don't understand what I mean by composition does not change. So let me give you an example there. That would be kind of looking at H2O in its liquid form turning into H2O in its solid and or gaseous form, right? The composition that we're referring to is this. And as you see, it has not changed. We still have two oxygen, hydrogen bonds, okay? And it's as simple as that. Okay, the composition did change. As always, the law of conservation of mass is observed, right? So we are not creating and or destroying atoms. We're basically moving them apart. And when I say atoms and or molecules, we're moving them apart, putting them together, moving them apart, putting them together, right? So we've caused no new substances are formed, right? I think that'll be the last thing I write. No new substances are formed. And so what that means is what we end with is very similar to what we started with, right? The final products are very similar to the initial substances. You might need to write that, final products similar to initial substances. What are some examples? Final products similar to original substance, right? Such that, so what's that though? We could say dissolving, right? You put salt and water. Those are my original substances. And what do I get? I get salt water, right? So they're very, very similar, okay? There is an argument as to whether dissolving salt and water is a chemical change or physical change, but we're not going to get into that. It's an old argument. There's good arguments on both sides, but my point is what we started with is very similar to what we ended with, right? Let's get that gone. So physical changes, or no, phase changes is what I want to say. Phase changes are physical changes, right? Phase changes. When you go from your solids to your liquids, liquids to solids, right, etc. Those are all going to be physical changes. You're just either adding heat or removing heat, but you're not breaking bonds and forming new bonds. You're not rearranging any atoms, okay? So now let's look at some chemical changes, right? In a chemical change, you are actually rearranging atoms. And in rearranging those atoms, you are either breaking and or forming bonds, right? I may just break bonds, I may just form bonds, or I may break these bonds and form new bonds. And in doing that, composition changes. Compositions change, what they're made of change, okay? Let's talk about that. And we'll talk about that again in a minute. And new substances with new properties are formed. Right? So what we end with is very different than what we started with. New properties are formed. We could look at, let's say, trying to think of some simple structures, right? So when these guys react, right? Well, the bonds here, we've got 4 hydrogen carbon bonds. And one day we're going to teach you how to draw these things. We've got an oxygen double bond. And when this reaction occurs, we end up with carbon dioxide and water. So we have essentially broken all of these bonds and broke this bond, this double bond, and we formed new bonds. Now we're going to have a carbon oxygen double bond and a carbon oxygen double bond. So we made some new bonds, we broke some bonds, and we made some new bonds. So we end up with totally new substances with a new composition, different compositions, and we don't have oxygen gas anymore. We have water vapor, and we have carbon dioxide, and we don't have any methane. So we've totally changed things around. And I think that y'all get that, right? So I'm going to continue. When we talk about chemical properties, right? Well, it's easier just to kind of list them off. First of all, you observe chemical properties when the substance is undergoing a chemical change, all right? So that they're not just blatantly obvious. They are observed during chemical changes, right? That's how we determine what the chemical properties of a substance are. So some examples of chemical properties would be like combustibility. Combustibility, something easily combusts. That means, you know, it can blow up very easily. Oxidizability. Something is easily oxidized. With an example of that would be iron. If you leave iron out too long, it's going to rust. So oxidizing is rust. Rusting is oxidizing. So that is a chemical property of iron and other metals, right? Acidity, right? Something is acidity, that's a chemical property. Alkalinity, that would be a chemical property. Where acidity talks about how acidic it is, alkalinity is going to talk about how basic it is, okay? So those would be some chemical properties of matter, all right? Now, we would then go to physical properties, all right? And those are easily observed, right? And you do not have to cause any changes to observe your physical properties, right? So you can observe these without changing the substance. All right. And what we need to do at this point is realize that there's 2 types of physical properties. We've got intensive physical properties. I'm gonna keep that there. And we've got extensive physical properties, and I need you to understand the difference between them, okay? So what's the difference? Intensive physical properties do not depend on the type, or I didn't mean to say type, my brain went in the wrong place. The amount, do not depend on the amount of matter present. And they will have the exact opposite over there. Let's go ahead and finish this. Properties that do not change when the amount of our substance that we're, observing changes. What properties are not going to change? whether I have a large amount or a small amount? Well, those are going to be like my density, right? The density of water is 1 gram per milliliter. If I have a drop of water or a huge amount of water, right? That's my drop of water. It doesn't matter how much of that water I have. It still has a density of 1.0 gram per milliliter. And the large sample has a density of 1.00 gram per milliliter, right? Because as the sample size goes up and its volume goes up, well, its mass also goes up, but the ratio of those stays the same. If the volume goes down, well, then the mass goes down and the ratio of those two values stays the same. Okay. Now, some other physical properties, right? So we've got density, we would say boiling point, freezing point, right? It doesn't, for example, this large sample of water is going to boil at 100 degrees Celsius. That's when it's going to boil. The small sample of water is also going to boil at 100 degrees Celsius. It's just not going to take that long, as long to get to that temperature. Freezing point. Well, the large sample is going to freeze at 0 degrees Celsius. And the small sample is going to freeze at 0 degrees Celsius. It's just going to freeze faster, right? Okay. And another intensive property that I didn't want to confuse you is your concentration of a solution, right? So the amount of particles in a certain volume, per volume, similar to a density, but different, right? So imagine that we have two samples of water and they, one is a large sample, and let's have salt water, right? So in here we have salt water, that's our solution, and it's got some salt in it. So I'll put 1, 2, 3, 4, 5, or I'm not gonna worry about it. And if I was to take and pour a small amount of this into here, right? That's kind of weird, I'm sorry. But if I was to take a small amount and pour it over here, well, I would have the same concentration, right? It's kind of like, here's my coffee with creamer in it. If I pour a little drop in here, it has the same concentration. There's the same amount of cream per coffee. It doesn't matter whether I have a huge cup or a small amount, the concentration will be the same. Okay, I know that drawing's a little weird, so I'm gonna go ahead and get rid of it. Okay, so those are, once again, put them in your head, they are intensive properties. They are inherent to the particular substance. And because they are inherent and do not change, we can often use them to identify substances. Oops, I do not want that. So these properties are often used to identify types of matter or substances, right? Is it water? Well, let's test its boiling point, its freezing point, and its density. If those match those of water, then we can conclude that this substance may actually be pure water, because we can't just drink it, right? We don't know what it is. So that's one way we could determine, is this actually water? Okay, our intensive physical properties do depend on the amount of matter present. Okay. Okay, that's cool. That's real simple. As the amount or the size or the volume changes, these properties change, right? So if I have a little bit of water versus a lot of water, oops, the property, whoops, sorry about that, guys. The property of, did all that work? Volume will change. The mass will change. The length will change, right? Those things are going to change if my sample size increases and or decreases, okay? So that's about it. We're going to keep it short and sweet. Quick review. We said physical and chemical changes in properties. In a physical change, atoms are not rearranged. Therefore, the composition does not change. And what we end with is similar to what we started with. We said law of conservation is observed in all changes, whether it's physical or chemical. We said that the final products are similar to the initial substances. In a chemical change, we see that we do have the rearranging of atoms. We're breaking and or forming new bonds. The composition therefore changes. We have new substances with new properties. And here's an example, right? We started with this and this. We ended with something totally different. And we then looked at what are some chemical properties. And these are properties that are observed while the change is occurring. You can't just look at it and go, oh, that's combustible. You got to actually put a flame to it to see, okay? You got to be careful with that one. And then we talked about the difference between intensive properties, and those are the properties that do not change when the sample size increases or decreases. And we looked at extensive properties, and those are properties that will change. They're easily observable. Nothing has to, you don't have to do anything to the substance, but they do change when the substance changes. I'm gonna add a couple of intensive properties here so that you know what they mean. Malleability, right? That's a property of metals, as is ductility, all right? And this means that you can easily shape or pound. You could make into long sheets is kind of what it means to me. Think of like aluminum foil, right? It doesn't come in a long sheet, but they can pound it and make long sheets. Ductility, you can form like pipes. These are kind of examples, right? So think of your ducts, like D-U-C-T, like long pipes going through your houses. That is an example. That's a horrible drawing. I got to get rid of that. Those are physical properties of metals that you can shape them and form them. And it doesn't really matter how much of the metal is present. You can still shape and form them, right? You can just get bigger or smaller shapes. Okay, I'm gonna leave it there because I got some more videos to make. So I will see you later. I'm gonna stop share and I'm going to end.